Welcome to the CyberOptics booth here at IPC Apex. I'm delighted to be joined by Subodh Kulkarni, the company president. Nice to see you again.
Good to see you too, Trevor.
Okay. So we're here to talk about essentially the SQ3000, which is your flagship machine. It has evolved over the years quite considerably, combining SBI, AOI, and CMM, the metrology, which is huge. But you've been taking it a couple of steps further. Perhaps you could maybe enlighten us on what the recent developments have been.
Sure. So fundamentally, SQ3000 uses what we call MRS technology. MRS stands for multi-reflection separation. It's a unique way of doing 3D non-contact optical sensing that enables us to get higher speed and higher accuracy both at the same time compared to other competitive approaches. In this next generation SQ, we call it SQ3000 Plus, we have taken the MRS technology to the next tier, and now we are using not only better resolution cameras like the 5 micron resolution camera for smaller components, but we have also adjusted the angles of the projector and the camera so we can truly look at very reflective surfaces like a silicon wafer or glass or something very reflective that normal SPI and AOI systems would struggle to look at because light just bounces around.
Well, the more you miniaturize, the more you're going to run into these types of devices.
Absolutely. Miniature devices, there are very reflective, but equally important, there are some applications like this mini LED, micro LED, which is taking off in a big way right now. You are essentially putting those small LEDs directly on substrates like glass. So you have to look at glass and inspect the small LED right on top of a very reflective surface. And for that you need these kinds of advancements where you have different projectors, different optics than your conventional way of inspecting. So we are really pleased to have that at this show floor here to show not only how you can get smaller components but also very reflective components.
I was talking to somebody yesterday actually about these micro LEDs and the number that you get on a tape or a disc actually. They come on these blue discs. Is that correct?
Right now, as far as I know, there's only 2 commercial products that are using mini LED in the market today. One is the iPad Pro, the other is the MacBook Pro, and those are roughly 300 micron diameter LEDs and spaced about 300 micron. The roadmap, and Samsung and LG did a nice job at the CES show in Vegas talking about the roadmap over the next few years. The roadmap for many of these large consumer electronics companies goes to LEDs becoming from 300 micron down to 30 micron, spaced at 30 micron apart. So when you multiply what a big screen television is going to need at 30 micron dots spaced at 30 micron, you're literally dealing with tens of millions of LEDs on one big piece of glass. And the need is to inspect each and every one of them and make sure it's accurately placed and doing the right stuff.
That's going to require a whole shift in the technology that you're using to be able to get that amount of coverage.
Absolutely. It's mind-blowing when you look at the complexity of the problem and the kind of cameras you need, the kind of image capture. But honestly, you don't have enough storage power to store every part of information. So you want to extract the higher level information and discard the data as it's coming along. Otherwise, you literally flood your system with petabytes and petabytes of data. So how do you get all that information? How do you process it? How do you use artificial intelligence to get the most valuable information for the process and then discard all the remaining stuff that you don't really need to store? It becomes a mammoth problem. So you not only need better quality optics, better quality projectors, better algorithms, but also better quality GPUs, better quality storage devices. So it just takes inspection to a yet another whole new level.
And how do you store the traceability? That data that you need to have some traceability on the process.
And that is a challenge. When you have tens of millions of mini LED dies or bumps or pillars like in the semiconductor industry back-end area, how do you know which one is you're looking at? And referencing that within the device itself is a challenge. When you do 5 things, it's not a problem. You can reference each one of them. When you suddenly start talking about 100 million things on one thing, keeping a reference, a datum, the accurate location is not a trivial task. And it is a computationally massively intense problem to solve. So it is a challenge right now.
I bet it is. I mean, but one of the things that CyberOptics is very well known for is developing sensors. So I'm guessing part of this roadmap is going to involve developing more sensitive sensors that can work on these things.
Yeah, I mean, our history for the last few decades now is to keep innovating clever things in the world of optics and keep bringing the best sensor technology we know how to do. And that's what MRS is all about. I mean, when we launched MRS in 2015, 2016, we launched it in SMT and semiconductor. It's really doing well, getting traction in both industries. Our market share has continued to grow nicely with MRS. With this next generation, we are taking on the next level of problems. We really feel pretty good about like getting into mini LED and some other very advanced electronic applications. But it's not going to end here. I mean, the SMT and semiconductor markets are converging. The needs are getting explosively complicated. Hybrid 2.5D, 3D, all of that is coming along. It's already there. Stacking of wafers is coming along. And need for inspection continues to grow. So we will continue to innovate in the world of sensors, coming up with better resolution, better accuracy, better speed. All the issues that you brought up, traceability, how do you do 100 million things without losing track of every single one of them. And it's a fun, intense problem to solve.
A fun one, it sounds like. But, this merging between the SMT and back-end packaging industry, are you seeing evidence of more EMS manufacturers putting clean room facilities inside the SMT factories?
Absolutely. I mean, we have had many interactions with customers right at the show floor who, like 5 years ago, nobody ever asked us about the kind of interfaces that semiconductor industry uses or even clean room standards. A lot of questions coming from customers are related to that. So you can clearly see where they are starting to come from. They realize that SMT equipment is no longer the conventional PCB industry equipment. They are moving into packages and hybrid devices. They need clean room, they need the semiconductor interfaces, and vice versa. When we go to Semicon, it's no longer the pure play semiconductor customers that we see. Some of the SMT people are going in those shows and asking us questions in those shows too. So we feel we see the perspective from both sides, but clearly convergence is going on as we speak.
I mean, I would imagine it's these micro LEDs and mini LEDs, are they being assembled in a clean room environment because of the form factor so small?
Absolutely. I mean, they are being assembled in class 1000 type facilities. Right. They are monitoring particles.
So that's likely to put the price of them up quite a bit, I would think.
Absolutely. No, these are very sensitive devices. Obviously, every piece of dirt, and dirt can be 20-30 microns easily, right, can destroy your pixel. Yeah. And 1 or 2 pixels, you may not notice it. But if you have 100 pixels missing on a big piece of glass, you will notice some weird problems with your display. So every piece of dirt becomes important. So things are moving in the convergence is clearly at play here.
I mean, the 30 microns is certainly a very small size, of course, but I mean, we're hearing stories in the industry of people moving down towards the sub 5 micron space. I mean, are you going to be able to cope with that?
Well, the way I look at it is, at least the current MRS sensor technology, we are using optics right now. So we are using visible wavelength. So the blue light we are using is 400 nanometer, which is 0.4 micron. So we think we can take the technology down to about a micron without losing the prowess of the technology. Right. So, and everything we have seen so far, whether it's the bumps pillars in the back end of semiconductor area, or the mini LED or micro LED in the electronics area, everyone is trying to take it down to 25-30 micron, maybe 5-10 micron as you suggested. But beyond that, nobody is quite thinking using SMT type processes or the conventional back-end semiconductor processes. Once you go sub-micron, you will have to go to the front-end kind of semiconductor processes. Then the technologies shift quite a bit. Then you are dealing with X-ray or UV or EUV, those kinds of technologies. So E-beam inspection, very expensive, very slow, but different world. But up to a micron, we feel pretty good about the MRS sensor technology and what we are doing right now.
Well, it's always great to see how you keep pushing the envelope, Subodh. So I want to thank you for telling us about it, and we'll be seeing the SQ3000 Plus, I guess, in its real form very shortly.
It should be in the US in the next month or so. So it's already on its way from Singapore, which is where we assemble our systems.
Right. Well, we'll look forward to catching up with that once it's here.
Thank you, Trevor. Good to see you again too.